To the engineering series. Today we're exploring the massive machines that built our modern world, cranes. From sky-high tower cranes dominating our skylines, to the rugged crawler and versatile all-terrain units, the massive floating giants that master the waves, specialized spider and railroad cranes built for unique environments, industrial overhead systems and the agile truck crane, and the vital ship-to-shore cranes powering global trade. This is Cranes Explained. Let's dive in. Have you ever wondered how those massive tower cranes stay upright? Today, we're breaking down the engineering marvels of the modern skyline. It all begins with the mast. These steel sections are bolted together and anchored deep into a massive concrete pad for stability. At the top sits the slewing unit. This massive gear and motor assembly allows the crane to rotate a full 360 degrees with precision. The long horizontal arm is called the jib. It carries the load, while the trolley moves back and forth to position the hook exactly where it's needed. To balance the weight, there's the counter jib. It holds heavy concrete blocks that provide the necessary leverage to lift tons of material. Inside the cab, the operator manages everything with incredible skill, often working hundreds of feet in the air. Engineering like this makes our modern cities possible. Next time you see a crane, you'll know exactly what's going on up there. Seen how tower cranes stay anchored, let's look at their more mobile cousins, the crawler cranes. Crawler cranes are known for their incredible lifting capacity and, most importantly, their mobility. Instead of a fixed foundation, they use a set of heavy tracks, allowing them to move across rough terrain. These wide tracks provide a massive footprint, giving the crane exceptional stability without the need for outriggers. Like tower cranes, they often feature a lattice boom, which is incredibly strong yet lightweight. Their defining feature is pick and carry, the ability to travel while holding a heavy load. Powerful diesel engines drive both the lifting winches and the tracks, making them self-contained powerhouses. This makes them the go-to choice for the heaviest lifts in industrial and civil engineering projects. Despite their size, they're designed to be disassembled for transport between job sites. From fixed giants to mobile powerhouses, cranes are the backbone of our built world. After exploring crawler cranes, let's look at the ultimate versatile lifter, the all-terrain crane. Designed to combine the road speed of truck cranes with the off-road capability of rough terrain models. These machines can travel at highway speeds and then navigate the mud and gravel of a construction site with ease. The secret is their advanced suspension and multi-axle steering, which gives even the largest models a surprisingly tight turning radius. Most feature a powerful telescopic boom, which can be extended quickly to reach impressive heights for any job. They are self-deploying, meaning they can be set up for a lift with minimal support equipment, saving time and money. With lifting capacities ranging from 40 to over 1,000 tons, they are true engineering marvels of the modern world. A perfect blend of agility and strength, these cranes keep our biggest projects moving. See you in the next one. At crawler cranes, let's move offshore to the true heavyweights of the sea, the floating cranes. Floating cranes, or crane ships, are specialized watercraft designed for heavy lifting in marine environments where land-based equipment simply can't reach. At their core, they combine naval architecture with heavy lift engineering, featuring high-strength lattice booms and massive winch systems. But the biggest challenge isn't just the lift, it's staying upright while doing it on a moving liquid surface. To maintain equilibrium, advanced ballast systems rapidly pump seawater between internal tanks to counteract the weight of the load. They also use dynamic positioning, a computer-controlled array of thrusters that holds the vessel's position within a single meter, regardless of wind or currents. Types vary from sheer leg cranes with fixed A-frame booms, used for immense capacity lifts like bridge sections and ship salvage, to semi-submersible giants that ballast down to reduce wave impact, providing a stable, floating island for ultra-heavy offshore projects. And floating cranes are the indispensable titans of the maritime world. Now that we've seen how floating cranes operate, let's look at their specialized cousins designed for the tightest spots, the spider crane. Formerly known as mini-crawler cranes, these machines are engineered to navigate areas where traditional equipment simply cannot fit. Their name comes from these multi-jointed outriggers. These spider legs can step over obstacles and set up on uneven surfaces like staircases. With low ground-bearing pressure, they are the go-to choice for rooftop work and interior glazing in modern skyscrapers. Most models feature dual power sources, diesel for outdoors and electric for silent, zero-emission indoor operation, all controlled via wireless remote. Safety is critical. Advanced load moment systems constantly monitor stability and automatically lock movements if safe limits are reached. Specialized searcher hooks even allow for under-the-eaves lifting in spaces with extremely low overhead clearance. From narrow alleyways to rooftop sites, the spider crane is the ultimate tool for high-precision lifting in restricted spaces. Continuing our series on heavy lifting, we're moving from spider cranes to the specialized giants of the track, the railroad crane. Built specifically for railway environments, these machines feature flanged wheels and a rotating superstructure designed for trackside lifting. Stability is key. On narrow track gauges, they use heavy outriggers to widen their base and advanced cant compensation to remain level on banked curves. In maintenance roles, they are the workhorses of the permanent way, precisely positioning miles of new rail and heavy signal structures. But their most dramatic role is recovery. These massive wreckers can lift over 250 tons, clearing derailed locomotives to restore service in hours. They've evolved from 19th century steam-powered units to modern diesel hydraulic powerhouses that operate under narrow overhead catenary wires. Even in transit, their design is unique, requiring specialized idler cars to support their long booms within standard train consists. From infrastructure repair to emergency recovery, railroad cranes are the indispensable guardians of the global rail industrial world, the overhead crane. Often called bridge cranes, these systems are the backbone of high-capacity material handling, moving massive loads across 3 axes. It begins with the bridge, the main girder that spans the width of the facility and supports the entire weight of the load. The trolley moves along this bridge, carrying the hoist. This is the heart of the system that performs the actual lifting. Depending on the facility, you'll find top-running cranes for maximum height or under-running systems that hang from the runway to save space. The key difference? While gantry cranes stand on their own legs, bridge cranes are permanently fixed to the building's elevated runways. Today's smart cranes use advanced software for sway control and soft starts, ensuring precision and safety in every move. From the first steam-powered designs of the 1800s to modern electric giants, their evolution is a feat of engineering. From steel production to aerospace, the overhead crane keeps industry moving. I'm your host, and we'll see you in the next engineering series. We're hitting the road to look at a machine that brings massive lifting power to any job site, the truck-mounted crane. Also known as boom trucks, these integrate a crane directly onto a commercial truck chassis, allowing them to travel at highway speeds. It's all powered by hydraulics. The truck's engine drives a pump that sends pressurized oil to cylinders, which raise, lower, and extend the boom. You'll typically see telescopic stick booms for quick setup, or lattice booms for extreme reach and heavy-duty industrial lifting. To stay stable, hydraulic outriggers extend like legs to create a wide base, preventing the crane from tipping under heavy loads. Inside the cab, a load moment indicator monitors every variable in real time, automatically locking the controls if safety limits are reached. Since the first hydraulic models in 1947, these mobile powerhouses have revolutionized how we build everything from bridges to skyscrapers. From highway utility work to major construction, the truck crane is mobility perfected. Now that we've seen how mobile cranes operate, let's look at the giants of the harbor, the ship-to-shore crane. Often called portainers, these massive structures are the critical gateways of global maritime trade, moving containers between ships and the dock. Since their debut in 1959, they've revolutionized the industry, reducing ship unloading times from 3 weeks to just a few hours. The core structure consists of a massive steel gantry and a hinged boom that extends over the water to reach across container rows. The hands of the crane is the spreader, which uses specialized twist locks to securely engage with the corner castings of a container. Modern cranes are built for speed, with trolleys reaching 300 meters per minute to maximize terminal throughput. To maintain accuracy, intelligent anti-sway systems adjust motor speeds to stop the load from swinging, increasing productivity. The future is electric and automated, with operators now controlling these giants from ergonomic stations far away from the quayside. From global trade to engineering precision, ship-to-shore cranes are the backbone of our modern world. Thanks for watching.